Section: Contents. In this section, we discuss how reinforcement learning, RL, with verifiable rewards has enhanced the reasoning skills of large language models, LLMs, in solving complex mathematical problems and generating code, leading to the development of large reasoning models, LRMs. We note that RL has also been applied to LLMs in contexts where they learn to use external tools, such as web search engines, to perform actions and observe real-world states. While models like Search R1 and Kimi V2 have shown strong performance, interacting with real web search engines can be expensive due to the extensive rollouts and multi-turn tool calls needed during RL training. We recognize that LLMs, having been pre-trained on vast web-scale data, can often answer questions that require world knowledge. Some research suggests that LLMs can act as world models by providing state information based on given actions. For instance, the Zero Search project shows that a fine-tuned LLM can effectively replace web searches, offering stable and reliable knowledge. This suggests that we can significantly lower the costs associated with Search RL by using a semi-real setting. Inspired by recent developments in unsupervised RL, we explore self-search RL in fully simulated environments, where no real searches are conducted during training. We focus on two main questions. First, what is the performance limit of LLMs on search-based question-answering tasks using only their internal knowledge? Second, can full sim search RL facilitate effective transfer of skills to real web searches during inference? We investigate whether an LLM can generate queries and information based solely on its internal knowledge, simulating the process of querying external search engines. To do this, we evaluate the LLM's intrinsic search capabilities on benchmarks that require web searching, prompting the model to simulate the search process through multi-turn, tool-formatted outputs. Our extensive sampling shows that LLMs contain significant world knowledge, achieving high predictive scores that follow a scaling law. However, extracting the best answer consistently remains a challenge, highlighting the gap between the knowledge stored and the ability to retrieve it effectively. To tackle this issue and explore the potential of full sim search RL for transferring skills to real-world applications, we examine self-search reinforcement learning, SSRL. This approach enhances the self-search capabilities of LLMs through format-based and rule-based rewards, allowing for autonomous refinement of internal knowledge without needing external searches. Our experiments reveal that models trained with SSRL outperform previous Search API-based RL models, such as Search R1 and Zero Search, across various benchmarks. They also act as cost-effective providers of implicit world knowledge, reducing instances of incorrect information in search-driven question answering. Furthermore, this method decreases reliance on external search engines and opens new possibilities for transferring skills learned through self-search to real online environments. In summary, we demonstrate that LLMs have significant potential to simulate web searches, serving as a resource for search-driven tasks without needing external queries. By systematically enhancing this self-search capability with SSRL, we set the stage for more autonomous and scalable LLM agents. Section Summary. In this section, we explore the potential of large language models, LLMs, to perform search-based question answering using only their internal knowledge, without relying on external search engines. We introduce self-search reinforcement learning, SSRL, to enhance LLM's self-search capabilities, demonstrating that models trained with SSRL outperform existing methods and can effectively transfer learned skills to real-world search scenarios. Section: Benchmarks. In this section, we evaluate our models across 7 benchmarks that fall into 3 categories of question answering tasks. The first category is general question answering, which assesses factual knowledge retrieval using datasets like natural questions and trivia QA. The second category is multi-hop question answering, requiring reasoning across multiple pieces of information, utilizing datasets such as Hotpot QA, Musique, Bamboogle, and 2Wiki multi-hop QA. The third category is vague question answering, which tests our ability to synthesize information from various vague prompts using Browse Comp. This evaluation framework allows us to assess capabilities from straightforward knowledge retrieval to complex reasoning and information integration. To ensure a thorough evaluation of repeated sampling effects, we conduct experiments with 3 model families: Qwen 2.5, Llama 3, including versions 3.1 and 3.2, and Qwen 3. We test models with a wide range of parameters, from 0.6 billion to 72 billion. For fair comparisons, we keep our sampling parameters consistent, setting temperature to 0.7, top K to -1, top P to 0.95, and maximum tokens to 8,192. The specific instructions we used are detailed in the appendix. We observe that predictive performance improves consistently across all benchmarks as the number of samples increases. For instance, on Bamboogle, the Llama-3.1-8b instruct model achieves an accuracy of 87.2% for a specific sampling condition, marking a significant improvement over its performance with just one sample. This trend is evident across all 3 model families, with the Llama series showing particularly strong benefits. In the Browse Comp benchmark, which has challenging search requirements but straightforward verification, we find that while some models perform poorly, others like Qwen 2.5-14b instruct and LLAMA 3.1-8b instruct outperform others when given enough samples. This suggests that large language models, LLMs, have substantial internal knowledge that can be effectively utilized through repeated sampling, even without external information. Interestingly, our findings reveal that Llama models outperform Qwen models in self-search settings regarding world knowledge, despite previous studies suggesting that Qwen models excel in mathematical reasoning. This indicates that the ability to self-search and reasoning skills may not be closely linked. Moreover, we find that the performance gap between smaller and larger models narrows with increased sampling. For example, on Trivia QA, the Llama-3.1-8b instruct model scores 81.2% with 1024 samples, while the larger LLAMA 3.1-70b instruct scores only slightly higher at 81.4%, showing that smaller models can perform comparably to much larger ones. In our experimental setup, we notice inconsistent results on the agentic search benchmark among different models. We analyze how efficiently thinking tokens are used in Qwen 3 models and compare 2 types of sequential scaling, multi-turn search and multi-turn reflection. We avoid truncating responses to maintain the model's capabilities and instead generate multiple responses to compare token usage under the same budget. We find that Qwen 3 models can operate in both thinking and no thinking modes, allowing us to adjust the number of thinking tokens before arriving at a final answer. Our comparative study shows that increasing thinking tokens in self-search settings does not necessarily lead to better performance, especially in long reasoning tasks. This suggests that the success of agentic search relies more on knowledge usage than on extended reasoning processes. Therefore, we conclude that shorter reasoning chains should be preferred in self-search settings to maximize token efficiency. Section Summary. In this section, we evaluate model performance across 7 benchmarks in question-answering tasks, revealing that larger sample sizes significantly improve predictive accuracy, particularly for Llama models. We also find that smaller models can perform comparably to larger ones with sufficient sampling, and that the efficiency of thinking tokens in Qwen 3 models suggests a preference for shorter reasoning processes in self-search settings. Section: Multi-turn self-search hurts performance. In this section, we explore how multi-turn self-search impacts performance. Following the common approach in search agent literature, we treat search as a multi-turn process and perform self-search for each rollout. After generating a search query, we prompt the model to provide relevant information, which we then integrate into the reasoning context, continuing this process until we reach a final decision. We refer to the number of interactions as n. Our method eliminates the need for external search engines, allowing us to avoid associated costs and constraints. We set n to 10 to ensure enough iterations for each sample to arrive at a final answer. Our findings indicate that naive repeated sampling performs better and shows consistent growth, emphasizing the inherent capabilities of language models as simulators of world knowledge. Next, we examine how self-search with reflection affects performance. The concept of the aha moment shows that language models can reflect and explore, especially in math and code tasks. To see if this reflective behavior applies to information search without external sources, we add phrases like, wait, 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 after each response to prompt the model to reconsider its reasoning. Our results show that, under the same token budget, this reflection does not improve performance compared to naive repeated sampling. Thus, we conclude that increasing the number of reasoning tokens and multi-turn generation may not always be beneficial in self-search scenarios, suggesting that utilizing knowledge might be more effective than reasoning alone. We also compare majority voting with pass at K. Our experiments reveal that while language models perform well in search and question answering tasks, identifying the correct answer from candidates remains challenging when the ground truth is unknown. This indicates that repeated sampling may represent the upper limit of test time scaling, necessitating further exploration of alternative strategies. Majority voting is often seen as a straightforward method for integrating with test time scaling. We use the MAJ at K metric to assess its effectiveness in knowledge-intensive tasks. Essentially, MAJ at K scores 1 if the most common answer among K samples matches the ground truth, and 0 otherwise. Our results show that increasing the number of responses for majority voting yields only slight performance improvements, suggesting that naive majority voting may not suffice for search tasks where incorrect answers can appear multiple times. Finally, we introduce self-search reinforcement learning, SSRL. Here, we use reinforcement learning to help language models extract world knowledge from their own parameters. We define the RL objective for our LLM-based search agent, which utilizes external search engines. In our approach, the model retrieves knowledge from its internal parameters rather than external sources, allowing us to simplify the objective function. We primarily use the GRPO training algorithm while also testing other RL algorithms to ensure robustness. We also investigate the impact of information token masking. Previous studies show that masking information tokens from external sources stabilizes training and enhances performance. However, since our retrieved information comes from the model's own generation, we question whether masking is still beneficial. We conduct experiments comparing training with complete reasoning trajectories to training with information masked trajectories. Our results indicate that information masking continues to improve performance, even when the information is self-generated by the model. Section Summary. In this section, we explore the limitations of multi-turn self-search and reflective reasoning in language models, finding that increasing iterations and reflection do not necessarily improve performance in search tasks. We also investigate majority voting and reinforcement learning approaches, concluding that while LLMs show potential as world models, precise knowledge retrieval remains a challenge. Section: Reward Modeling. In this section, we employ a combined reward function that includes two signals, format reward and outcome reward. We determine the outcome reward based on the accuracy of the model's final prediction, which compares the true answer to the predicted answer. Our iterative search process requires models to break down complex questions into smaller, manageable parts, focusing on specific information with each step. Therefore, maintaining a clear output format is essential for effective reasoning. To support this, we introduce a format reward that encourages adherence to a structured reasoning approach, as detailed in the appendix. The final reward integrates both components, with a specific weight set to prioritize accuracy while ensuring structured reasoning. For our evaluation, we assess performance across 6 benchmarks, excluding browse comp due to its high difficulty and limited training data. We use the same validation sets as previous studies to ensure a fair comparison. Our evaluation method is strict, considering a prediction correct only if it exactly matches the true answer, which helps us robustly assess model performance. To evaluate the effectiveness of our self-search method, we compare it against several baseline approaches: vanilla prompt methods, which include direct prompt and chain of thought, RAG-based methods, such as standard RAG and Search O1, and RL-based methods, including R1, Search R1, and Zero Search. We perform offline evaluations of our models while allowing online testing for baseline methods where applicable. In online settings, we limit the number of retrieved passages to 3 for all RAG-based methods. For the vanilla prompt methods, we use instruction-tuned models, which have shown better prompt following abilities. Details about the baseline implementations can be found in the appendix. In our training setups, we focus on the Llama model family, specifically LLAMA 3.2 to 3b and Llama-3.1-8b, chosen for their effectiveness in repeated sampling scenarios. We combine the NQ and Hotpot QA training datasets to ensure a mix of general and multi-hop question answering. Our primary training algorithm is GRPO, but we also test other methods like PPO and Reinforce++ to confirm our results. All training occurs on a single node with 8 NVIDIA A800 GPS. For GRPO, we use a batch size of 256, a learning rate of 1 millionth, and 62 warm-up steps. The maximum response length is set to 4096 tokens. For policy optimization, we set the temperature to 1 and generate 5 rollouts per prompt, applying a small KL divergence coefficient. Each model is trained for 5 epochs, and we select the best performing checkpoint based on validation accuracy to avoid overfitting. During evaluation, we set the temperature to 0. We present our main experimental results in a table and include case studies in the appendix. Our findings show that models trained with internal retrieval outperform those using external search engines, whether from other language models or Google search. We also see better performance compared to R1-like models trained with a simple chain of thought prompt. These results indicate that with well-designed instructions and rewards, language models can effectively serve as both reasoners and knowledge retrievers, extracting relevant information from their internal knowledge without needing external sources. Instruction-tuned models utilize internal knowledge more effectively. When trained on the same data for the same duration, these models perform significantly better than their base versions, suggesting they incorporate additional knowledge operations during fine-tuning. However, this advantage is context-dependent. Instruction-tuned models excel when relying on internal knowledge, while base models perform better when external information is available. This suggests that different strategies are needed for optimizing internal versus external knowledge use. Finally, we observe that larger models demonstrate better self-search performance. The training curves show consistent growth in training rewards. Early in training, both response length and search count decrease as models adapt to format reward constraints. In later stages, LLAMA 3.1 to 8b Instruct develops more advanced strategies, learning to break down questions and reflect on their responses, leading to improved performance on our benchmarks. Section Summary. In this section, we describe our approach to reward modeling, which combines format and outcome rewards to guide our model in producing structured, multi-step reasoning while ensuring accuracy in predictions. We evaluate our model against various baselines, demonstrating that our self-search method outperforms others by effectively utilizing internal knowledge, particularly in larger instruction-tuned models, while also highlighting the need for different strategies depending on the availability of external information. Section: SSRL is more efficient and robust. In this section, we demonstrate that SSRL is more efficient and robust. The training curves for Zero Search and SSRL show that SSRL significantly improves training efficiency, cutting training time by more than 5 times. We also observe that SSRL maintains steady reward growth throughout training, indicating its strong performance. Although SSRL starts with lower training rewards compared to Zero Search due to limited external knowledge, its efficiency and robustness make up for this initial shortcoming. Next, we explore Sim2 real generalization. While SSRL performs well on static benchmarks, the fixed knowledge in these models limits their use in real-world situations. We investigate whether SSRL can adapt to real-time search settings. Since our trained model matches the format of Search R1, we can easily incorporate real search capabilities, which we refer to as sim-to-real generalization. We replace model-generated information with actual search results from Google or local databases, substituting up to a certain number of self-generated responses. To ensure compatibility, we modify the retrieved information to align with our training data. Our experimental results show that performance improves with more maximum turns across all models, except for LLMA 3.1 to 8b instruct. SSRL-based models generally outperform Search R1 and Zero Search in sim-to-real settings, demonstrating that agents trained on internal knowledge can effectively use external sources when the formats align, leading to reduced training costs and improved efficiency. We also find that LLMs have substantial internal knowledge, suggesting they should only search externally when necessary. Based on this, we propose an entropy-guided search strategy. For each generated sequence, we analyze the uncertainty of the initial search query. If uncertainty increases, we trigger an external search. Otherwise, we rely on internal knowledge. We use sim-to-real, all, as our baseline and always perform an external search for the first query, as shown in our results. This approach reduces search frequency by 20 to 42%, resulting in significant cost savings while maintaining performance similar to full external searches. Although LLAMA 3.1 to 8b instruct struggles under sim-to-real conditions, it performs better than sim-to-real, all, indicating challenges in leveraging external information due to differences between self-gathered and external data. These results reinforce our key finding that LLMs can effectively use their internal knowledge when relevant information is available. In our exploration of test-time reinforcement learning, we examine unsupervised RL algorithms like TTRL, which show promise in math and code generation. We conduct experiments on the Llama series using various datasets. Our analysis includes ablation studies with and without information masking while keeping the format reward component essential for label voting. We find that training with TTRL yields better performance than with GRPO, with an average improvement of 59% for LLAMA 3.2 to 3b instruct. This suggests that TTRL generalizes well across different domains and model families. Interestingly, we observe that smaller models achieve higher scores on browse comp with TTRL. These models tend to identify an entity first and check if it meets requirements, contrasting with the typical search and answer approach. This supports our view that LLMs contain valuable information that can solve complex questions once accessed. We also test sim-to-real on TTRL-trained models, finding that while TTRL outperforms RLVR, it introduces biases, leading models to overly rely on internal knowledge and struggle to adapt to real environments. Most queries are resolved with a single search, indicating that web search engines lack the flexibility of LLMs. Additionally, TTRL-trained models prefer to select and verify candidate answers rather than sequentially searching based on questions, and they tend to collapse more frequently than RLVR due to the deterministic behavior of policy models. We provide a case study to illustrate these findings. Section Summary. In this section, we demonstrate that SSRL is more efficient and robust than Zero Search, achieving a 5.53 times reduction in training time and steady reward growth, despite initially lower rewards due to limited external knowledge. We also explore sim-to-real generalization, showing that SSRL can effectively integrate real search capabilities, and propose an entropy-guided search strategy that reduces search frequency while maintaining performance, highlighting the ability of LLMs to leverage internal knowledge effectively. Section: Benefits of Information Masking. In this section, we discuss the benefits of information masking. Since all the information we retrieve comes from our reasoning model, training it on both reasoning and information generation is a natural way to optimize performance. We conduct experiments to compare training with and without information masking, and our results show that information masking consistently improves model performance across various benchmarks. Our analysis indicates that masking information during training encourages the model to create more detailed reasoning paths, which explains the performance improvements we see in different question answering tasks. By preventing the model from merely copying information, this strategy promotes deeper engagement with the reasoning process, leading to stronger problem-solving skills during inference. Next, we explore the impact of format-based rewards. To effectively harness the dual capabilities of language models as reasoners and search engines, we design a format reward that ensures adherence to our structured reasoning framework. This reward helps models consistently follow a structured approach to thinking, searching, and gathering information. Through ablation studies, we compare models trained with and without this reward, and our findings show that the format reward enhances performance for both base and instruction-tuned models across all benchmarks. This highlights the importance of structured output formatting in combining reasoning and search capabilities. The format reward acts as a guiding mechanism, helping the model maintain organized reasoning paths that support effective knowledge retrieval. Without this guidance, models tend to produce less coherent reasoning, which diminishes their overall performance. We also notice a significant increase in response length when the format reward is absent, indicating that it stabilizes the training process. We then address the importance of on-policy self-search. In previous work, the fine-tuned language model acted as an information provider. In our approach, we treat the policy model as a simulator of world knowledge, simplifying training and reducing costs, especially for multi-turn rollouts. We examine two scenarios, one where the policy itself provides information and another where a frozen policy does. We apply an information mask and a formatted reward throughout the training. Our experiments with 4 models from 2 different families reveal a sharp decline in performance after about 100 training steps, with rewards either stagnating or dropping significantly. We also see a notable performance drop when using a frozen model as the information provider. Next, we present the compatibility of our approach with various reinforcement learning algorithms, including PPO, GRPO, Reinforce++, DAPO, and KL-Conva, using LLAMA 3.2 to 3B instruct and LLAMA 3.1 to 8B instruct as our base models. Our results indicate a significant performance difference among the algorithms, with GRPO-based methods outperforming PPO and Reinforce++. The effectiveness of repeated rollouts for training search agents is also confirmed. While training with online engines like Google incurs higher costs, our offline training allows for more rollouts without additional expenses, leading to better performance. Finally, we discuss reinforcement learning with search engines. RL has proven to be a powerful method for enhancing the reasoning abilities of language models. RL-trained models, which use either process or outcome rewards, show impressive results on complex tasks like math and code generation through self-reflection and exploration. Recent studies have applied RL to improve LLM-based search agents, but these methods often rely on static textual corpora, which do not capture the complexity of real-world online searches. To overcome this, online search RL has been introduced, aligning trained models with web search engines. While this approach achieves better performance, it incurs high API costs. As a cost-effective alternative, Zero Search suggests using an LLM as a search engine simulator to create a synthetic online search environment, significantly lowering computational costs while maintaining performance. However, the potential of LLMs as world models for reinforcement learning in search tasks remains largely unexplored. Section Summary. In this section, we demonstrate that information masking during training enhances model performance by encouraging deeper engagement with reasoning processes, while a format-based reward ensures structured reasoning and effective internal knowledge retrieval. Additionally, we explore the compatibility of various reinforcement learning algorithms and highlight the advantages of using LLMs as search engine simulators to reduce training costs while maintaining performance. Section: Large Language Models as Search Engines. In this section, we discuss how advancements in large language models, LLMs, have led to a new approach called generative search. This method allows users to access flexible and detailed information through generation instead of relying on traditional matching techniques. Our research on using LLMs as search engines focuses on two main strategies. The first strategy, generative retrieval, involves directly creating document identifiers without needing explicit matches, with each identifier linked to a specific document in the collection. This approach assumes that LLMs have internalized the information, acting as an implicit knowledge base. The second strategy, reliable response generation, uses LLMs to summarize retrieved content, like academic papers and web pages, producing user-focused responses as search results. These methods overcome limitations of traditional information retrieval systems, such as inflexible document structures and relevance matching, while offering improved flexibility, efficiency, and creativity for real-world applications. We see that LLMs could function as world models, providing knowledge for searches based on keywords. However, there has been limited investigation into their use as textual world models in reinforcement learning contexts. Next, we explore inference time scaling of LLMs and agents. Repeated sampling involves generating several potential outputs from the same prompt using probabilistic methods. We find that the accuracy of correct answers significantly increases with more repeated samples. This is supported by findings that show a rise in the percentage of correct answers captured, even in difficult benchmarks. Similar improvements have been noted in code generation tasks. Beyond simple repeated sampling, we can enhance these methods by integrating verification techniques. Approaches like best-of-n sampling and majority voting utilize multiple samples with different selection criteria, leading to better performance than single greedy decoding. However, the effectiveness of repeated sampling in information retrieval and search contexts is still not fully explored. Additionally, recent advancements in text-to-speech (TTS) have uncovered a largely untapped design space for language-based and embodied agent systems. We systematically examine various TTS strategies for language agents, showing the benefits of parallel sampling, reflective revision, and diversified rollouts. Agents, such as web agents, demonstrate superior adaptive behaviors like exploration and backtracking, outperforming traditional methods when applying scaling test time interaction. We also introduce a GUI test time scaling agent, which uses concurrent sampling and evaluation to improve robustness in graphical user interface tasks without needing extensive foresight. Complementing these strategies, we present multi-agent verification, where multiple verifiers work together to assess outputs, significantly enhancing overall agent performance. Together, these studies highlight various approaches to TTS in agent systems, emphasizing the potential of both computational strategies and interaction methods to improve adaptive and robust behaviors across different environments.